Okay.
Alright, I'm back. Now we've got the little motor. I mounted it back in its frame that came out of the microwave oven. And as you can see, I've wound roughly 250 turns here on this motor. Much heavier wire. See if I can get that where you can see the difference. Much heavier wire because the current's going to be higher, because the voltage is going to be lower. So I've got an old analog meter here, amp meter, so we can see the secondary current, and about a 10 to 12 volt transformer, something like that here. Same watt meter as before. Let's plug it in. Oh, and I've wrapped extra turns around so we'll be able to see a bigger meter deflection here. It multiplies the reading when you do that. There you go. It's running on about 10 volts at the meter. Yep, 11 volts. Passes the finger test. Makes power. And let's take some readings off our watt meter here. And it looks like 10.5 watts. Power factor's 40.4. 238 volts feeding into the transformer. And 0.11 amps. It was designed for 15 volts. We're running it slightly under voltage, so none of that is a big surprise. And you can see the amp meter reading here. It's multiplied. And of course at 15 volts, at 10 volts, 12 volts, it should be, to get 10 or 12 watts, should be about an amp. Okay, it's going to be a little more because we have reactive power. Let's see now. Remember that power factor reading, 0.4. Let's throw some capacitors across things. Whenever you work with capacitors, it's always a good idea to make sure they're discharged before you touch any terminal on a capacitor. Okay, let's fire it up again. Power factor is now 0.47. And any motor, just like a transformer, when you load it, the power factor will rise. Keep watching that power factor. I'm going to load it up with my little finger here. Power factor going up. And of course the amps went up. See if I can get the watts to go up. Watts going up, power factor comes up. That's the nature of it. Now, the amp meter reading is dramatically less than it was without the caps. Remember that reading about mid-scale. Get the caps out of the circuit. Big difference in power, in current rather, same power. Still 10.5 watts. What, 10.5? Current high. And back things back up, current's lower, same power. That's the importance of power factor demonstrated for you. Also, with just the transformer connected, you can also see the power factor change. Let it settle there. 0.39. Unhook the capacitor. Power factor falls down, 0.23. And here we go. That's just the capacitor current there. Add the motor back in. Yeah. Well, it's going to fight back. There we go. And you can see as the motor accelerates, the current drops down because you have some counter EMF here and there. Current goes up, power goes up. No surprises there. This concludes this little demonstration.